we're now looking at what's known as arithmetic progressions. Now we can say that 2, 5, 8, 11, 14 is an example of an arithmetic progression, AP for short, with a common difference D equals 3 and the first term A equals 2. And some notation on this. Let's consider that third term there, the third term of the sequence. We would say that the third term T3 is equal to 8. So the term 3, that capital T, little 3 there, indicates the third term. Now a few formulae we have to remember. Tn is equal to A plus n minus 1d, and S of n, the sum of n terms, equals n on 2 outside of 2a plus n minus 1 times d, where a is the first term, d is the difference, and n is the number of terms. So those two formulae are very important that you remember those. Now that sum formula, the S of n terms, the sum of n terms, can actually be written as a much shorter way. We can write that as S of n equals n on 2 outside of a plus l, where l is the last term. So if we know the last term, well then we can use that short formula. So we'll just jot up there, l is the last term. Very good. Now what makes an AP an AP? Well, the condition for an AP is this, that the difference has to equal term 2 minus term 1, which will be the same as term 3 minus term 2, which will be the same as term 4 minus term 3, the previous term, and that of course will just continue on right throughout the progression. So let's just check this out. Term 2 minus term 1, well that will be 5 minus 2, and that's why we get a difference of 3. That's why the difference is 3. What about jumping up to say term 4 and term 3? So term 4 is 11, term 3 is 8, and we go 11 minus 8, again we get the difference of 3. Terrific. Let's look at an example now. We're asked to write down the nth term of the sequence 7, 5, 3. Okay, that sequence continues. Then in part B, calculate the sum of the first 20 terms. Well, let's solve part A firstly. There's our sequence 7, 5, 3. It's going down by 2. It's going down by 2. So therefore we write the difference equals negative 2. Alright, it's going down by 2. Difference is negative 2. We can see that's the first term. So we write A equals 7. And the question wants us to do, write down the nth term. So there's our term formula. Tn equals A plus n minus 1 times d, which we can then write as such. And all we've done there is replace the A with 7, and the d, the difference, being negative 2. So Tn equals, well firstly we have that 7 there, then we need to expand the brackets there. Now each term inside the brackets is being multiplied by the negative 2 outside, so one at a time. If we go negative 2 times n, we get minus 2n. The negative 2 times negative 1 will give us positive 2. So Tn therefore equals, and we simplify that, collecting the like terms, we have 7 plus 2 is 9, so we have 9 minus 2n. Okay, now the nth term, there we have it, Tn, that's the nth term, sometimes known as the general term. The general term. Terrific. Part B. Calculate the sum of the first 20 terms. Well, we're talking about the sum, so we're looking at the sum formulae. So we write S of n equals n on 2 outside of 2a plus n minus 1 times d. So firstly, we're talking about sum of 20 terms, so we write S of 20 equals n on 2, where n is 20, so we have 20 on 2. Then in brackets, 2 times a, where a is 7. N minus 1, well we know that n is 20, we're talking about 20 terms, so 20 minus 1 is 19. And we're multiplying the 19 by the difference, which is negative 2. So if that simplifies, we work that out on the calculator. It works out nicely to be negative 240. Excellent. Let's look at another example now on sequences and series. Now just to recap, for an arithmetic progression, okay, AP for short, there are our two formulas for term and sum. A is the first term, D is the difference, N is the number of terms. Or remember, if we know the last term, we can use the shortened version if we're asked to find the sum. Now the 10th term of an arithmetic sequence is 15, and the 16th term is 39. And we're asked to find the value of the common difference, the D, and the first term, which is A. Well, because we're talking about terms, we'll write down our term formula. Now firstly, the 10th term is 15. The 10th term is 15. So we'll consider what T10 would be. Using the formula, we'd get A. Now the n minus 1, well, we're talking about the 10th term, so n is 10. So 10 minus 1 is 9. So we'd get 9D. So we'd get A plus 9D as the 10th term. We're told though it equals 15. So we set it equal to 15. Very good. We're going to do exactly the same technique for the 16th term. So T16, again, firstly it's A using the formula above, and then we have the n minus 1. Well, n is 16, so 16 minus 1 is 15, so we have 15D. And we're told, highlighted up the top there, the 16th term equals 39. Very good. At this stage then, a couple of simultaneous equations, we'll call them 1 and 2. So we're going to subtract, and because we do that, we'll get rid of the a's. So the a's will go, a minus a, that's gone. 9d minus 15d gives us minus 16. 15 take away 39 eventually equals to minus 24. So let's solve that. Minus 6d equals minus 24, works out therefore d is equal to 4. So we found the common difference. We substitute this into equation 1 because we need to find a. So instead of d, we're going to replace that with 4. So we have a plus 9 times 4 equals 15. Works out to be a plus 36 equals 15, and solving that, therefore a equals minus 21. So as our final step, we should just jot down what we have. D equals 4, a equals minus 21, therefore the difference is 4, and the first term is negative 21. Terrific. Our final question for this lesson, again sequences and series. The sum of the first n terms of an arithmetic series is given by this. S of n equals n outside of 3n plus 5 all over 2. We're asked to calculate S of 1 and S of 2. Part B, find the first 3 terms of the series. And finally, find an expression for the nth term. Right, part A. Write down our formula that we're given. S of n equals n outside of 3n plus 5 all over 2. Therefore S of 1 equals, okay, in other words, what have we done? We just replaced n with 1. So if we do that, we come up with that. That simplifies to be 4. We're asked also to find S of 2, exactly the same method. Where we see n, we're going to replace it with the number 2, and that simplifies to be 11. So part A is done. We found S of 1 and S of 2. Moving on to part B, find the first 3 terms of the series. Well, what does S of 1 actually mean? Well, it actually means that the first term adds to 4. That might seem a little bit odd, but we'll just write that down. The first term has to be 4 because S of 1 means the sum of the first term. So it's got to be 4. What about S of 2? Well, S of 2 means the sum of the first 2 terms. So the first 2 terms add to 11. So if the first term is 4, we need to think of a number that when added to it makes up 11, and that number would have to be 7. So we can see that we have 4, 7. Right, the question there asked for the first 3 terms. So far we have 4 and 7. Well, we're given that as arithmetic. which means it goes up by the same difference. Well, it's going up by 3, so the next term has got to be 10. So that's our first 3 terms of the sequence there. Very good. Part C, our final part. Find an expression for the nth term. Well, this is an AP. It's got an A is 4, the first term's 4, the difference is 3. So there's our formula for the nth term. So we simply write Tn equals 4 plus n minus 1 times 3, and that simplifies. Once we expand the brackets, we get 4 plus 3n minus 3, and finally